All right, this video I'll be looking at simplifying rational expressions. So we're going to simplify. We're also going to state any restrictions. So with most of these problems in section 7.3, the name of the game really is we have to factor. That really is what we have to do. Anytime we're stuck and we're like, well, I'm not really sure what to do, usually factoring is involved. So I have this expression. I have 7x cubed minus x squared divided by 2x to the third. First thing I'm going to do is I'm going to try and factor the top, and then I'm going to try and factor the bottom. So up top, I'm looking at 7x cubed minus x squared. So I'm looking for, right there, I'm looking for a GCF, something I could pull out of both of these terms. So I have a 7 over here and negative 1 over there. Can't really do much with that. I have an x cubed and an x squared. So what I can do is I can actually pull an x squared out of both of those pieces. So I'm going to take an x squared out of both of these pieces. If I do that, the 7x cubed is now just a 7x. If I take an x squared away from an x squared, I still have that like minus 1 right there. So I have a minus 1. So that is my factoring up top. I have x squared times 7x minus 1. On bottom, I'll try and factor that as well. I have 2x cubed. Not a whole lot you can do there, so that's going to stay as 2 times x cubed. Now, once I'm factored, before I do anything else, what I like to do is I like to figure out my restrictions. Now, what we're looking at with restrictions is we're dealing with rational expressions or rationals. Remember, rationals is like fractions. The one thing we want to avoid is we do not want the denominator to ever equal 0. So we're looking at what can I plug in for different variables to make the denominator 0. So this 2 has no effect because 2 times x cubed. So I don't want x cubed to equal 0. Well, let's solve that just for a plain old x to figure out, well, what do we not want x to be? Well, if I want to get rid of a cube, I take the cube root of both sides. Cube root of 0 is 0. So one thing I want to avoid, and this is a restriction here, is I want to avoid x being 0. Because if you plugged in 0 for x, you're going to get a 0 on bottom. We're going to have issues. We don't want that. So after I've done my restrictions, I can get back to the problem and simplify. Now what we're looking for is we're looking for common factors on top and bottom, or simplifying how we simplified back with exponents in an earlier chapter in Algebra 2. So the one piece I'm looking at is I have an x squared up top and I have an x cubed on bottom. So I have 2 x's on top and I have 3 on bottom. Well, if I take away 2 from the top and take away 2 from the bottom, well, I had 3 on bottom, I'll just have 1x left over. I can't really do anything else because that 7x minus 1 is all packaged together. So what I'm left with there is a 7x minus 1 on top and just a 2x on bottom. So all I did there in this problem is I took out a GCF and then used properties of exponents there. I had an x squared up top and an x cubed on bottom. So when I simplify there, I just get a single x on bottom. So my answer here is 7x minus 1 divided by 2x with a restriction of x cannot be 0. So let's go to one more example. I have x squared minus 3x minus 18 divided by x squared minus 7x plus 6. So always remember the name of the game is factor. So I'm going to factor the top. So I'm looking for two numbers. Since this leading coefficient is a 1, there's no GCF there. Looking for two numbers that multiply to negative 18 but add to negative 3. Multiply to negative 18, add to negative 3. That's going to be negative 6 and positive 3. So I'm going to get x minus 6 and x plus 3 in the top, or the numerator. We're also going to factor that in denominator. So I need two numbers that multiply to 6, add to negative 7. It's going to be negative 6, negative 1. So now that I've factored, what I would like to do is I'd like to talk about restrictions again. and I want those figured out. So remember, we do not want the bottom equal to 0. We do not want any of the bottom to be 0 because we cannot divide by 0. So what I'm going to do is I'm going to take each factor, set it equal to 0, and solve. So we want x minus 6 cannot be equal to 0. If I want to solve that, I add 6, and I get x cannot be 6. That's one of my restrictions. So if I plugged in a 6 here, you're going to end up with 0. And then also I have x minus 1 is not equal to 0. If I solve that, so I took my other factor, set it not equal to 0. Add 1, x also cannot be 1. So from the bottom, I took each factor and basically I set it equal to 0 and solve, and that's helping you find those restrictions. So x cannot be 6, x cannot be 1. So back to the problem, what I'm going to do is once I'm factored, notice how I have an x minus 6 on top and bottom. So that's the same piece on top and bottom. So those two pieces, that divides to 1. So when we simplify, those two pieces are gone. So all I'm left with on top is this x plus 3 piece. And on bottom, I'm left with x minus 1. So my simplified answer is right there, x plus 3 divided by x minus 1 with restrictions. X cannot be 6 and x cannot be 1. And that was simplifying rational expressions.